Hello again, and welcome to week 10, the final week. We're going to end this workshop by talking about how to make a tool in Bifrost. What I mean by that is how you can make something to give to another artist, something that is controlled through Maya. As a technical artist, you will be setting up the inputs, the settings, and two different outputs in this project. Now, here's the tool that we're going to use. So you should all have this file open at this point. What I've got here is essentially a instancer that makes power lines along a curve. So this is a Maya curve here. You can see it there. You can get to its control verts. You can pull those control verts around, thereby changing the instancing, all of that good stuff. It's a good little setup, and it is used extensively in both gaming and VFX as something to instance along a curve. Right. The trick for this one is that the wires are generated in Bifrost. So as you can see here, I've got instances coming out and strands coming out. If I turn the strands off, that's just a simple instance. So what we're going to do very first thing is go through this so that you guys understand it. This is as much a lesson about using stuff other people have given you than it is about building a tool, because you're not always going to build all of the compounds you need. This one is pretty vanilla. There's not much custom going on here, but we're going to need to do some custom stuff for the background. So in that vein, I'm going to need you to download and install 2 packs. All right, the first one I want you to download and install is my one, which lives here. So this is my compounds directory here. This is the one you want. Oh, I haven't signed in, but you'll need to just download this as a zip file and install it to Bifrost. Now, to install something to Bifrost, you just unzip here. That's obviously me, but uses your name, Autodesk Bifrost Compounds. We've done this before, just doing a quick run through. The other one that I want you to download and install for making this tool is Maxine, which you can find here. And I will put the links into the lesson. But before we start going off and doing that, let's get these installed, because we're going to need them for our output, especially our output to a game engine. And in this lesson, we're going to set this up as a tool for any studio. So I'm going to show you how to do both kinds of outputs. One is going to be rendering in Arnold. The other one is going to be through USD to a game engine. Okay, so let's have a quick look through this so that we're familiar with what it does. What we've got here, these are our curve inputs. You can see here that if I change which curve here, zoom out a bit, there's our first curve, which is this one, our second curve, third curve, fourth curve. So this allows your users to drag in as many curves as they would like, or draw a new one and connect it. I'm going to show you how that's done as well, which is one of the first things we're going to set up. So right now, these are input by taking a curve and just dragging and dropping it into Bifrost with the middle click. That's turned up there for some reason. We need to change that. We need to change that to make this a proper tool. Before we go ahead and start doing the Maya side, what I want to do is just go through this. Now pay very close attention to the green boxes, because the green boxes will show you where you need to put controls. So in this case, number of instances, that controls how many power poles there are across the curve. If I go in here and just bring this up a bit, you can see it changing. So that's our first control. The second control you've already seen, it's which curve are we putting it on. Then we move to rotations. This allows us to rotate our power poles, as you can see. And you can see that the strands, the black strands, are following with them. I'll explain how that's done in a minute. We can also randomize our rotation. Maybe not in the X. Let's set this to, say, 10 degrees. And you can see that the poles are now leaning. If I play with the seed, you can see what that does. So that's our next control, randomization of the rotations and any rotations we want to set. Then we have cull wires, and that's pretty simple. How many wires do you want? Like that. And then random culling. see what happened there? What this is doing is it's culling the poles. So if I set cull max to 0.15 and cull min to 0.1, you can see one of our poles has disappeared and the wires are still okay accordingly. So that's going to be our next setting. We've got another one here. This is just the seed. We'll talk about that when we get there. Random per wire. Let's see what that does. So keep an eye on the wires. So this randomizes the sag per wire pretty much. And again, you've got a seed here. You can see the sag changing. This just allows you to get not exactly the same sag every time. Then there's our sag controls. So strand point count is how high the resolution is of that. If I take this down to 4, you can see that they've gotten really chunky. And there are times you're going to want them really chunky. If you're working on a stylized game, if you have a very large amount of these and you don't want it to calculate all of the points, there's all sorts of reasons you could set that low. I've set that to 20 for now. And then let's just change the background. Then you've got the sag itself, so I can make them sag more or even reverse it, should I want to. Per pole minimum and per pole maximum. This controls how much sag per pole. At the moment, it's both set to 1. So it's a random number per pole. So it's set to 1. So what you're getting is just the sag value right now. But if I start pulling this up, you can see I'm getting different sag values across different poles, which is a good thing. It's one of those naturalistic additions so that it looks more natural and less generated. Then we have cull by pole, which is, this is the chance of a wire being cull by pole. So you've got a system whereby you can have 3 wires on this pole, 4 wires on this pole, 3 wires on this pole, etc., etc. Those are the controls we need to put in. Now, obviously, before we put the controls in, you're going to need to know how they work. And that's what we'll do now, is I will go through and explain to you how these actually work. And we're going to start with the count controls. Even though this is all talking about instances and things, there are no instances happening here. The instances don't happen till this point in the graph. What I'm doing here is I'm setting up everything I need to make those instances work properly. So the number of instances is the number of points that we are putting along this curve. Probably the best way to do that is we'll just chuck in a point scope. This is just a little bit of diagnostic. It's good for you guys to see this. And then a terminal. These are going to come out black, so I'm going to change my background color. And let's make them a bit bigger. So that's the points of the original curve. And you can see that the poles don't sit on those points. What I'm doing here, if I move this along, is I am resampling that strand. And you can see that even though you can't see the strand, this curve is still the Maya curve, you can see that if I make these just a smidge bigger, the strand is being resampled. So the curve coming in is being resampled to have this many points. And you can see this constant count here is coming from instance count. And instance count is plugged into instances. And here's our first thing. I have found, when I built this, quite a long time ago, I think this was 2021 I built this. When I built this, I found that if you had less than 4 points in a strand, that Bifrost and Maya will sometimes crash. Now, that's possibly not going to happen anymore because it is quite a few versions on, but better to be safe than sorry, especially when you're dealing with a studio environment, when you're giving this tool to artists, and artists above all need it to be stable and easy to understand. So all I'm doing here is going, how many instances has my artist put in? Is that less than or equal to 3? If it is less than or equal to 3, make it 3. If it's not, just use what they put in. This is a simple safeguard. It's kind of like a minimum clamp. It's only going to clamp the low values. So if it's less than or equal to 3, it becomes 3. And that controls how many poles we have later on. This gets into the resample goes into the random cull, and you can follow the resample, gets its basis updated, gets some orientations put onto it, and then it goes into the instances. So that's how this count is directly controlling the number of poles we have. So I can go to count controls again, we can just push that up, and you can see the points on the curve. The resample is calculating the points on the curve, and we're just instancing a pole on it. That's how that works. As far as the controls for the control curve, again, this is just taking in a number. It's taking in a integer, and in here, it's clamping it. So it's taking, this is our number coming in. In this case, it's 4, because I have 4 curves. This is which curve we're asking for. We're getting the array size, decrementing it by 1, and just clamping it between 0 and that number, which in this case, it's 0, 1, 2, 3. So it's 3. Converting that back to long and just outputting it. Then we're getting that curve from the array of curves we have coming in and outputting it. That's what this does. So we're going to need to put controls on these two, which is why there's a green box. With me so far? It's pretty simple when you start breaking it down, and as well as how to build a tool, as well as how to deal with artists, as well as all of that sort of stuff today, we're also, again, going through what happens when someone gives you something. So a senior gives you something and wants you to turn it into a usable tool. This will happen a lot, especially as a junior and as your skills get up. So it's good to know before you do anything else, before you just think to yourself, yeah, I can do this, this is easy. Go through the graph, make sure you know absolutely what it's doing. If you don't know, ask the person who gave it to you, because they don't want you to screw it up either. We've covered the count controls, we've covered the resample strands. Let's have a look at how cull wires works. Now this is a little interesting because what this is a matrix array. It is the positions of, let me really quickly show you. If I hide my Bifrost just for a second, and we go into instances, attachment points, let's show those. And we'll isolate the selection. So if we show one of the poles, now the poles are what we're instancing. There's two of them, one that has this little transformer on it, one that doesn't. So if we show the poles, you can see that these attachment points are 4 locators. And as I said, I built this quite a while ago. So nowadays, if you want to get a locator into Bifrost, you just drag it in. There it is. But back in the day, I didn't have that. So I've basically attached them as an array within the node editor to this array input here. And what this does is further along, and I'll show you, you can see it snaking off up here. Further along, what happens is it uses these attachment points on each instance to start and end the wires. So if this array at the moment has 4 in it, if this array has all 4, then every pole will have 4 wires. If it has 3, every pole will have 3. And so that's how we're culling the wires. So let's get this back to the way we had it. We'll hide that and show that. Oh, we might want to show the paths. Let's show the paths. There we go. That's back to the way we had it. And we'll just focus in on the Bifrost again. Okay. So essentially what I'm doing when I instance is I am copying all 4 attachment points onto the instance. But I'm doing this procedurally, so I'm not copying all 4. I'm copying however many come out of here. And the way this works is, takes the array coming in and it gets the array size, first of all. Clamps it, turns it into long, and then uses a slice array. And what a slice array does is pretty simple. It takes an array, it starts at this value and stops at this value. So it cuts a slice out of the array and then provides it to you. Stride is just, do you want to do it by 1s? Do you want to do it by 2s? Do you want to do it by 3s? In this case, 1. So if I have this set to number of wires being 2, you can see here, and you notice that it was 14 and it still only showed 4. That's what this clamp is doing. And it's exactly the same as we did for the curve input, except what we're doing is clamping the upper value instead of the lower value now. So if I set this to 3, then you can see I've only got 3 wires, and that is the slice of the array. So all 4 come in, always. This is where we decide how many go out to being instanced, etc. And we're going to need to put that out as a control. So that's pretty simple. Pretty simple. We've made a little green box so we know that it's coming out as a control. Let's look at something a little more complicated, which is the rotations. So you might notice that there is no points coming in here at all. Okay, so the only thing that gets attached here is how many instances we have. What the rotations compound does is essentially just make an array of the rotations for us. Now, I'm assuming that my artists are putting in degrees, so the first thing I do is convert them to radians, basically so that Bifrost can work with it easier. But again, this is a tool thing. Most artists, some will know how to work with radians, but most won't, and they'll prefer degrees because that's what they grew up learning. When you go and do geometry at school, at least where I went to school, we got taught about degrees, not about radians. That came much later. So I'm converting to radians for Bifrost to use, and what I'm outputting from here is a rotation array. So I'm taking whatever rotation is set here in degrees. So that could be, oh, I don't know, it could be like, let's just do 45 degrees. There you go. Everything's turned 45 degrees. So this is now 45. Well, this is 45 degrees. This is the radian equivalent. And to that, I am adding a random array based on the instance count. So when the randomization is 0, like it is here, it's just adding zeros to this. And that means that what's coming out is an array with 45 in the Y for as many instances as we have. As soon as I start randomizing, you can see that there. What it's doing is making a random array of the same number of instances we have, and it's spitting out a vector, or in this case, a rotational vector, but we'll get onto that. Then it changes the range of that to the radians of our randomization, and it takes that you've input here, in this case it's 36, go to 30. It negates it to make it negative 30, or whatever that is in radians. That goes into the 2 start, the 30 goes into the 2 end, and it's just changing the range of this random array from 0 to 1, which is what it is to default, to whatever we've put in, and then adding that to what our rotation is. So if I set that to 0, this is going to be a random rotation of 30 degrees in the Y. You can see that they're rotating different amounts. And you can really see it when I start changing the seed that they rotate different amounts. So that's how that one works. The controls we need to put in for this one are rotation, randomization, and seed. Random cull. This one, again, should be pretty easy. So at this point, this is the first one we've done after we've resampled our strands. So all the resampled strands are this curve resampled to give us the points we want to instance on. Resampling, this is not a spatial resample because a spatial resample calculates how long your strand is and then resamples it based on the amount of space you want between the points. What this is a constant count, which is what allows us to go, how many poles do we want? Or we want 11, we want 20, whatever. Because it's a constant count, it will just resample that strand to have that many points in it. And this strand goes out, the first thing it goes out to is the random cull. And what the random cull does is gets the strand, gets the number of points in it, makes a random array of that size, which is a float, so it's from 0 to 1, changes 0 to 1 to the cull minimum, cull maximum that you set, 0, 0 at the moment, and then just uses that as weights on a cull points compound, which pretty much just does what it says on the box, right? Randomly deletes points on a point object such as a particle system based on weighted probabilities. So we're just using the weights here. It's a multiplier on the probability port. That's it. And this tells you how the weights work. We're then outputting the deleted indices, so the indices it's deleted, I've taken the strand, got its point positions, and I am literally removing positions from the array based on these deleted industries, rebuilding the strands here, and out it goes. Because there is only one strand that we are instancing on. And this is what this is working on. Which means that if I go in here and set this to 0.05, 0.15, you can see I still have points coming out of my resample strands, which is what the point scope is showing us. But not all of those points have instances on them anymore. And so that's how I'm randomly culling instances from the resampled strands. Reset that, and those are the two controls we'll need to make here, plus of course a seed. So it's at this point that the tool goes off and actually does a bunch of stuff, which is what these guys are. And we don't really need to work on these. There's no inputs needed up here. But just so you know what the tool is doing, this is where our instances come in. Random cull spits out that master strand. The basis is updated, so we end up with a strand that's carrying a normal, a binormal, and a tangent. We're converting that to orientation. This is how we get our rotates. Those go straight into instances, and the instances by themselves, they are literally just the poles. There are no wires here. The wires are built here, and the main thing that builds the wires is this, and it builds them per attachment. Okay, so it gets the attachment array that we talked about when we were culling wires, converts it to an SRT, scale, rotate, transform. This is in a loop, so it's looping through that array. It's rotating by quat with the quat that we've got coming out from here. So when we set our orientation, which is based on our rotations calculation, so that goes out to there, and this is the radians that it's rotating the basis by, the basis orientations by. We get the orientation out. That goes into here. And we are rotating the attachment points by that quat. And then this is our instance position. These are the black dots. We're adding our attachment points one by one in a loop to those positions and then outputting the positions. And what that gives us coming out here is the position of each attachment point along the instance curve. We then split that into wires using a for each loop. And literally what this is doing is taking the whole array, getting its size, decrementing it by 1, building a sequence array that starts at 0 and goes up by 1, then uses each of those sequence arrays to build a 2-point array that starts at each of these sequences and goes up by 1. So what you get then is, what this is splitting this into is this point and this point, this point and this point, this point and this point as nested arrays. So if you have a look there, that's array mathlib3. That is an array of all the start points and end points of the wires, where the wires should go. So we get those positions from the incoming position array. We output that. Then we output that straight out. And then we just make strands out of that. And this is literally making a 2D array of strands, which we can then flatten and just use. That's the big secret of how we're putting wires on things. It's quick, it's easy-ish, and it works very well. So these two are the main engine of this tool. But then we need to do some stuff here so that we can add more naturalistic stuff to it, right? So this is just making a random array of the same size as the number of wires we've got coming out, and it's an array from 0 to 1. When there's a 0, it's just 0 to 1. So this is where we're just using this array to make a random per wire, and we had a look at that before. So this is what's affecting the sag. Again, we're not actually doing anything, we're just making numbers to use in this right now. This just gets the size of the wires array, makes a random array out of that, multiplies those random values per wire. So remember that's 0 to 1. Adds 1 and the minimum to it, and then outputs it. Pretty simple. And that's just numbers that we're using to make it sag. Now, how do we make it sag? Okay, so you've got all of these coming in. You've got random per pole here. This goes to another random generator. You've got the random sag value, which is what we just made here. And that comes in here. We're just multiplying the two together and the sag value itself. And the sag value is this guy. And it's literally how much do the wires sag. Once we've got all of that those numbers worked out, we are resampling the strands, which before this compound are 2 points, 1, 2. We're resampling it to have some resolution along the wire, which is what this number does. Remember, we set that to 4, they got really chunky. 6, they're still chunky. 24, they're going to be nice and smooth. That's what this numbers does, and it's another resample strands with a constant count again. You could go in here and hack this to be a spatial resample, but I would hazard to suggest that you're going to get way too high-res wires for your game engine if you do that. This way you can literally control how much goes in. See, if you use 10, it's still a little bit chunky, but it might work for the style you're building, that kind of thing. So we get those point positions, and we update the strand ratio. Now what this does is it makes a point ratio from the 0 point to the 1 point. Here's how we set the sag. So this is the sag curve. Rather than do a very heavy catenary calculation, because these are inverse catenary curves basically, rather than do that, which is very math heavy and can slow things down, all I did was build a curve that's close enough. It's a cheat. It goes from 0 to -1 to 0, so it's always hanging down. And it goes from 0 to 1 in the x-axis. So that it's a cheat, but it's faster than the alternative. Then we take the y value. This is the resampled strands. These are the y values of those strands. So before the sag's applied, literally everything looks a bit like that. Not that you can see it, but everything looks a bit like that. We get the y value of that point position, and we're multiplying this curve by this number that we worked out that gives us our random per pole, our random value for our random per wire, and the sag value. That gets multiplied by this F curve here, which is working on the point ratio. That gets added to the y value, and then everything's recombined, so the x and y values from the points are recombined with the new y value, and out we go. Then we rebuild our strands. So that leaves us with these strands that we've got now. And that's how the sag works. I believe lastly, but of course it's not last because we have to build a whole output module here, we're culling by pole. So what we've got here is the strands coming in. It's getting the array indices of that array. And that array is all 4 strands times however many poles you've got. Getting the indices, making a random value based on that, and says, if that value is less than the chance that our users put in, then find the true ones and remove them from the array, which is how we can get wires disappearing per pole. Which means if you wanted to do a nice sort of apocalyptic thing or broken wires or whatever, this would be what you'd use to do that. It's something I put in a bit later because I thought it would be a good thing for, some artists to do. The trick about making a tool is trying to give the ability to do anything people can come up with in the simplest way possible. I mean, it helps if you've been an artist and done this kind of thing. If you haven't, it really helps if you know someone that does and you can talk to them. Okay? So here endeth the explanation of how this works. You should have a reasonable idea of how this works now. If you don't, listen to this bit of the video again, go in, poke around, make changes, disconnect things, reconnect things, save yourself a copy so you've got a backup, and see how it works, because it's super important that you are au fait with this, you understand how this works before you start making controls for it. I can just give you the finished file, which I've done, and you'll learn nothing. You'll just like, oh yeah, he's just plugged things into the controls, and mostly that's what I've done. But what's going to happen here is a fairly big output rig, and we're going to build that together. All right, so let's get on to actually connecting what's inside Bifrost to what's inside Maya. Let's do our inputs first.